Today we're going to talk about the relationship between sine and cosine. So the first thing we're going to do is answer these questions in reference to the diagram below. The sine of A. So if A is the angle I'm referring to, this is my opposite side, this is my hypotenuse, and this is my adjacent side. Sine is O over H. So my opposite is A, my hypotenuse is C. Now I'm going to erase that because the next question refers to angle B. So my adjacent and opposite will switch. Let's check it out. If I'm referring to angle B, this is my opposite side. C is still my hypotenuse, but A now becomes my adjacent side. Cosine is the ratio of adjacent over the hypotenuse. The adjacent side is A, the hypotenuse is C. Question 5 also refers to B, so my diagram is already labeled. But it's the sine of B, so I need O over H. My opposite side of B is lowercase b, and my hypotenuse is C. And then lastly, I'm going to need to find the cosine of A, which again means I'm going to need to erase this. Referring to A, opposite, hypotenuse, adjacent. Opposite of A is lowercase, opposite of A is lowercase a, but cosine is the ratio of adjacent over the hypotenuse. Adjacent is B, hypotenuse is C. What term can we use to describe angles A and B in this diagram? Angles A and B are complementary angles. Complementary angles have a sum of 90 degrees. They're complementary because the third angle in that triangle is a 90-degree angle, and we know that all angles in a triangle have a sum of 180 degrees. What observations can you make regarding the sine and cosine of angles A and B? The sine of A was equal to the cosine of B, and the sine of B was equal to the cosine of A. Based on these findings, we can state, I'm going to write one more thing, which is that the sine of an angle is equal to the cosine of its complement. And that's a super important phrase we're going to use this lesson. So based on these, if I have the sine of x, I can say that it's going to be the cosine of 90 minus x. And then if I have the cosine of x, it's going to be the sine of 90 minus x. Complementary angles. Let's fill in the blanks. If I have the sine of 20, that would be equal to the cosine of, these angles should be complementary. Again, that means that they have a sum of 90. So 90 minus 20 gives me 70. Sine of 33 What's 90 minus 33? 57. Sine of 55. Cosine of 35. And lastly, the sine of 60 is the same as the cosine of 30. These two angles need to add up to 90. So if I have 1, I can subtract it from 90 to get the other. Now we're going to determine the value of x. If the sine of x is equal to the cosine of 31, how are we going to determine what x is? Well, we just said up top that these two angles should add up to 90. So that means that I can take x, add 31, and set that equal to 90. If I subtract 31 on both sides, x should be equal to 59. Same thing for 11. These two angles should add up to 90. So I'm literally going to write an equation where those two degree measures will be equal to 90. Then I can solve. "12 and 13 get a little bit harder. Let's see. Sine of x minus 4 is equal to, this should say the cosine of 50. So the sine of 50, or x minus 4 is equal to the cosine of 50. Well, these two together should be equal to 90. So I can say x minus 4 plus 50 equals 90. I'm going to combine some like terms. And subtract from both sides to get x is equal to 44. The next one, sine of 2x plus 14 is equal to the cosine of x minus 5. These two should equal 90. So I'm going to add their sum to equal 90. Here are my like terms. I get 3x plus 9. That was bad math. Subtract 9 from both sides. 3x is equal to 81. And x is equal to 27. Not too bad, guys, right? Let's try one more. We're going to find the value of k that will make the equation sine of 74 is equal to the cosine of k true when 0 is less than k is less than 90. What this means is that when k is between 0 and 90 degrees. And then we're going to explain our answer. So to find our answer, we already know what this is going to be. Basically, it's like an x, right? We can either take 74 and add k to equal 90, or we can just subtract 74 from 90. But in either instance, we'll get the same answer. K is equal to 16. Now it says explain. So we're going to explain and we're going to say the sine of an angle is equal to the cosine of its complement. Again, there's that phrase that I said before was super important. So if it says to explain, that's what you're going to write. That's the big takeaway from today's lesson of the relationship between sine and cosine.